Okay, hello grade 9s. Okay, hello, hi. Yes. Okay, guys, so we are rolling up for a session for grade 9s. All right, this is a grade 9 session. The grade 9 session will be followed by a grade 10 session, and then the grade 10 session will be followed by the grade 11 session. So we'll be doing back-to-back sessions, grade 9 now, grade 10 afterwards, grade 11 afterwards. Okay, grade 9 now, grade 10 after, grade 11 afterwards. Okay, yeah. Gladys, what grade is Gladys in? Yeah, thing is, guys, you need to understand that sometimes what I would ideally like to do does not always work according to plan, and I'm having also some serious network issues where I am concerned. You know, for instance, this morning my network was very bad, very bad. Okay. Yes. I mean, that will happen. Okay, that will happen, but not now. I mean, as I said, that session will happen. All right, it's just that it will happen a bit later than what I anticipated. Right now, I'm having a session with the grade 9s, so if you will just be patient, okay, then that will be also amazing. Yeah. Yesterday I had a session with the grade 9s, and I also sort of like said that I would continue today. So I'm doing a grade 9 session now. I'll be doing a grade 10 afterwards, and I'll be doing a grade 11 afterwards. So this is like, I'll be trying to give everyone equal time. But the grade 9 session shouldn't be too long, because what I want to do with them is I want to just establish some of the things that we covered yesterday, because in order for me to start with grade 9 officially, we need to make sure that the grade 8 work is really sorted, right? So there's a few problems or game challenges that I'd like us to do today with the grade 9s, and hopefully through these game challenges and these problems, we can be able to sort of like establish once and for all some important concepts that we should have covered in the grades that we're coming from. Right, so the first question, okay, and we've already covered the content yesterday, but the first question that I want us to look at is the one that basically, yeah, I had given for exercises, because yeah, I want to do some of the corrections for that work, right? So yeah, there's a few things that I'm picking up which I think need to be addressed very quickly. The sooner they do, the better. Okay, so grade 9, this is grade 9. So if we're looking, for instance, at if x is equal to -12 and y is equal to 4, then it says determine the value. Determine the value of the following expression. Okay, let's look at a few. Let's say if we are given that x is equal to -12 and y is equal to 4, we are asked to determine the value of this expression. Let's say the expression x minus y. All right, so obviously you guys know that x is equal to -12, y is equal to 4. How do I approach a question like this? I mean, obviously the value of x is given to me, the value of y is given to me, so I need to substitute. Now when I substitute, guys, please, we always substitute using brackets. Okay, we substitute using brackets. So x in brackets is -12, y is +4. Okay, Then of course, to remove the bracket, we know that will be negative half. Minus times positive will be negative 4. And then all we do now is we subtract the fractions. All right, we just subtract the fractions. Now, you know, guys, whenever you added and subtracted fractions, you know that the important thing here is to find what we know as the LCD between 2, and obviously 4 can be written as 4 over 1. So the LCD between these two, you know, is the number 2. Okay, and then of course, how do you know that 2 is the LCD between 2 and 1? It's because between 2 and 1, the lowest common multiple between 2 and 1 is 2. Okay, then what does that tell you? You need to align each denominator. So what would you multiply 2 by to get 2? You multiply by 1. But what you do at the bottom, you do at the top. Same thing with minus 4 over 1. We multiply to get the LCD 2. We multiply by 2 in the denominator. So what we do in the bottom, we do where? At the top. And then that gives us minus 1. Negative 1 times 1 is 1. And then over 2. Minus 4 times 2 is negative 8 over 2. Okay. And then of course, the final answer will be, when the denominators are the same, there's a rule that in fractions, when the denominators are the same, that allows us to add and subtract the numerator. So our final answer then is what? Is negative 9 over 2. And we just leave that answer in that form, in the fraction form, and that should suffice for your grade 9s. Okay. You can come back in the next 2 hours, until long. Okay, that's when I'll be doing the grade 11. That's when I'll continue the grade 11. But for now, it's grade 9, and then afterwards it will be grade 10. Okay, let's look at another one. Okay, so we're still saying when x is equal to negative half, y is equal to 4, we want to find the value of the following. Let's look at this one. What about when we are given the expression x minus y, the whole thing squared? Okay, so our value for x is negative half. Our value for y is 4. And then we are told that we have to square the entire thing. Okay, so now that we are in this position, obviously we are going to remove the brackets for the individual numbers inside the bracket, which means negative half minus 4, the whole thing squared. So remember, guys, whenever we are dealing with something like this, we need to always remember BEDMAS, okay, because we have brackets and we have a exponent on the outside. Now the thing is, we need to first take care of brackets, and we can see that inside the brackets we have a subtraction of fractions, right? And I mean, we dealt with a subtraction of this nature of fractions inside the bracket. So basically what we are being asked to do is we are being asked to do the same thing here. So obviously the subtraction of the fraction will mean we have minus 1 over 2, and here we have minus 8 over 2. Okay, and this minus 8 over 2, remember, where does it come from? It comes from the fact that our LCD between 2 and 1 is 2. And then obviously we want to make sure that our denominator, okay, is like the 2. So we multiply by 1 at the bottom here, we multiply by 1 at the top there. For this 4 over 1, we multiply by 2 in the denominator to get the LCD 2. We multiply by 2 in the denominator, and that's what we get. Remember, there's a square, so we don't forget that. Now that the denominators are the same, we can subtract the numerator. So we get negative 9 over 2, the whole thing squared. And then here, guys, now we can apply the square because we have a single term inside the bracket. And this is what is important. This exponent does not get applied to 2 terms inside the bracket. It cannot be. We have to resolve what's inside the bracket first, then we can apply the exponent. Now, when we apply the exponent, it means the exponent that is even gets applied to the negative sign first. So if an even exponent is applied to a negative sign, what does that lead us to what sign? What sign do we get? Because remember, we apply to the sign, the number, the letter for the single term inside the bracket. We check if the single term, does it have a sign? Does it have a number? Does it have a letter? So according to this, if we apply the even exponent to the negative sign, we get an answer that is it negative or positive? That's the question. Okay, so we get a positive answer. Then the 9 squared, the 2 squared, and this is coming from the laws of exponents, okay, that we multiply the exponent with the exponent of that particular base. So this is 9 to the power 1, but 1 times 2 gives you 9 to the power 2. 2 to the power 1. 1 times 2 gives you 2 to the power 2. Then what is 9 squared? It is 81. What is 2 squared? It is 4. And then we leave the answer in this state. So the answer is 81 over 4. Please, guys, all right? Certain individuals in the group sent me their responses to the questions, and I was very shocked, guys, to some of the things that some of you are doing whenever you are substituting and simplifying. Some of you don't really take into consideration BEDMAS at all. Some of you don't know that you cannot, for instance, apply the exponent to 2 terms inside the bracket. You can't apply this exponent to negative half alone and then apply the exponent to negative 4 alone. You know, you have to first add or subtract what's inside the bracket. BEDMAS is important. You first look at your bracket, check, can you do anything inside that bracket? If you can, simplify it. Then you move on to your exponent. So you can see after the subtraction of the fraction inside, when we got 9 over 2, negative 9 over 2, then we could do the next step after the bracket, which is to apply the what? The exponent. Bracket, what do? Subtract the fractions. So we did that. Next step, exponent. Once there is one term inside the bracket, we can officially apply the exponent. But when we apply the exponent, guys, please, you apply the exponent to the sign, to the number, if it is there, and to the letter. And in this case, when we apply the even exponent to the negative sign, it gives us the positive answer. We apply the exponent to the number in the numerator, the number in the denominator. We got 9 squared and 2 squared, which give us 81 over 4. That's very important, all of that, step by step. Okay, let's look at another one that I gave you guys. Here's another one. 1 minus 3x cubed. We are asked to do what? If x is equal to negative half or y is equal to 4, find the value of. So x is negative half. We need to determine the value of the expression. So we write down 1 minus 3. In the place of x, what do we substitute? Is it negative half or is it y is equal to 4? Which one? So obviously we substitute a what? A negative half. So there it is, negative half to the power 3. Okay, now then we simplify. Now you can see that here we have something where we can see that there's different operations. There is 1, which is a term, and it's separated from minus 3 into this bracket to the power 3. So we need to remember who? BEDMAS. Meaning brackets get first priority. Okay, so for now our 1 will stand there and wait, minus the 3 will also stand there and wait. We need to attend to what is inside the bracket, but what is inside the bracket is 1 term. So that means we can move on to the next thing, which is we need to attend to the exponent. Our exponent can be applied to the single term inside the bracket. When we apply that exponent, what do we need to remember? We need to remember SNL. In other words, the exponent that is odd. This is an odd number exponent. When we apply this odd number exponent to the negative sign, what happens to the negative sign? It stays negative, doesn't change. All right. We apply the exponent now to the number, the numerator and the denominator. This is 1 to the power what? 3. 1 to the power 3 over 2 to the power 3. Okay, now I can simplify further. 1 minus 3 into negative 1 over 8. Okay, guys, this is very important. Okay, and I mean, if you are going to get marks for showing me what you've done step by step, this is how you will be able to get your marks. Your unpacking of BODMAS, your application of BODMAS in the order, brackets, you know, exponents. When you are looking at the exponent, applying it inside that bracket, make sure it's one term. If it's not one term, you need to simplify what's inside. If it's one term already, then you need to remember an odd exponent applied to a negative sign leaves us with a negative. Then you apply the exponent to the number in the numerator, the number in the denominator. 1 cubed over 2 cubed, which gives us negative 1 over 8. Now we can move on to the next step, because our exponent, we've exhausted the step of exponent. Is that division? No. Is there multiplication? Yes. Brackets mean multiplication. So this one needs to stand and wait still. Now we take the 3 and we multiply it with the negative 1 over 8. Negative 3 times negative 1 over 8 gives us positive 3 over 8. Multiplication finished. We move on to the next thing. Is there addition? Yes. Of what? Of fractions. Okay. And obviously this is 1 over 1. Our LCD between 1 and 8 is 8. So then we go ahead. We find the LCD. We know that we need to align our denominator so that it is in line with the LCD. 1 times what will give me the 8? It will be 8. So what I do at the bottom, I do at the top. Then 3 over 8. The denominator is already 8, so I just multiply by 1 and 1. This gives me 8 over 8 plus 3 over 8, which ultimately, when the denominators are the same, what do I do to the numerators? I add the numerator, so I get an answer of 11 over 8. Thank you so much, Senande. How kind of you. Very, very kind. Okay. People, you see, BODMAS is the way. It's the way to actually help us simplify in order. You must simplify in order. If you don't do that, guys, you are going to always be getting wrong answers and you're going to be losing marks unnecessarily. So I've just shown you how to step by step be able to do this. Okay. Yeah, I hope you are cool with that. Okay. Yeah. So number D, let's look at another one. Let's just say one more with the substitution thing. Let's look at this one. The cube root of negative 5x cubed plus 2y plus 7. Okay. Negative 5x cubed plus 2y plus 7. So the cube root of that, okay, for our grade 9 learners, the cube root of negative 5x cubed plus 2y plus 7. So remember, we said where if x is equal to negative half and y is equal to 4, determine the value of the expression. So if x is equal to negative half, so in this expression we are going to substitute in the place of x the value of negative half. In the place of y, we are going to substitute the value of 4. Okay, there it is. Okay, then the next step in this process, what do we do? Okay, we have a negative 5, we have a bracket, negative half to the power 3 plus 2 times 4 plus 7. So once again, inside the cube root, we need to first consider what? BODMAS. Why do we consider BODMAS? It's because inside we have many operations. Okay, many operations, too many. Okay, so the cube root can just chill and wait. We need to sort out what's inside this cube root. Okay, so let's go. We've got a negative 5. Negative 5, you must chill when. We've got a negative half to the power 3. Now I can just apply my simplification very easy here. You see this negative? there's an odd exponent. I know an odd exponent applied to a negative sign. This is a bracket. It means I can actually do the brackets and the exponents for this term here. So 3 exponent, if I apply to a negative sign, it stays negative. Then of course, if I apply the exponent to the 1, it's 1. If I apply the exponent to the 2, it becomes 2 to the power 3, which is 8. So I have a negative 1 over 8 plus, here's another 2 and a bracket. Brackets mean multiply. This is a separate term altogether, so I can deal with it. 2 times 4, that's 8 plus 7. Okay, I'm coming. Now, this negative 5 times this negative 1 over 8 is also a bracket. I can deal with it as well. The cube root can wait for now. This negative times another negative. Remember what a negative times a negative gives me? A negative times a negative gives me a positive. So I have a positive 5 over 8 plus 8 plus 7. Okay, so that means now I can actually simplify what's inside the bracket. You see, I've been able to resolve this term because it had a negative 5 times this. But please guys, you can't multiply this negative 5 with a negative half without first taking care of the bracket and its exponent. It is not allowed to multiply negative 5 with the half before you actually apply the exponent to the negative half. Then you can take the negative 5 and multiply. Okay, so this way of BEDMAS is the way to go. The brackets, the exponent next, negative 1 over 8. Then now, because the exponent has been taken care of, you move down the ladder. There's division, then there's multiplication. So this negative 5 can now be multiplied with negative 1 over 8 because the exponent has been taken care of. Okay. Would it be wrong if you were to first cancel the cube root by inserting brackets with the exponent? Yes, totally and completely it would be wrong. Why? Because this is an expression, guys. You can't put a bracket around this and to the power 3 to remove the cube root, because this is not an equation. This is an expression. So for an expression, we are given the cube root of this. Right? So we need to work with this and simplify this as it is given to us, as it is. All right. You by actually taking raising this to the power 3 with a bracket and canceling the cube root, we are changing the expression that we had been given, and we can't do that for an expression. This is an expression, guys. Please, we can't do that. Right? So that is not allowed. All right. So grade 9s, I hope you are clear with this, because these are the basic things that I can tell you now. You see what I'm saying here with this thing of applying BEDMAS. Too many students are not following the rules. And as a result, this is what happens. In grade 11 and 10 and all of these other grades later on, people are still struggling with this simple basic simplification because people are not applying BEDMAS, right? Yeah, I don't know how many times I've had to call on my grade 12s even and tell them, no, you can't take this negative 5 and multiply this negative half without first resolving the exponent, okay? Because some of them they just don't, they don't take care of following the rules as learned in the previous grades, okay? So now that we are here, we can add the fraction 5 over 8 plus 8 plus 7. All right, okay, so obviously guys, 5 over 8, this is 8 over 1, but we know that the LCD will be obviously 8 because we can see the denominator there is like that. This is 7 over 1, but we know we are going to times that by 8 so that we have the LCD as appropriate as we want it to be. Okay, so guys, denominator is 8. This is 8 over 1. This is 7 over 1. So our LCD is 8, of course. Then what do? we go to each denominator, we multiply by that LCD, we multiply by the number that will give us the LCD. So for each denominator here, it is multiplication by 8 that will give us the LCD 8. But what we do at the bottom, we do at the top. What we do at the bottom, we do at the top. And then ultimately, this is 5 over 8 plus 64 over 8 plus 56 over 8. When the denominators are the same, what did we learn in the previous grades? That if the denominators are the same and we are adding and subtracting, now we can add the numerators. I want someone to tell me, what is 5 plus 64 plus 56? What will I get in that numerator? Because all of this will be captured underneath the cube root. 5 plus 64 plus 56, guys, gives me okay, 125. Right, nice. And then of course, you guys know everything that you need to know about a cube root. Any root, if you have a fraction, obviously that root can be applied in the numerator and be applied in the denominator. So what's the cube root of 125 alone? Because we can split the cube root. For division, we can split the cube root. For multiplication, we can split the cube root. It's only for addition and subtraction that we can't split it. We split it for division. 125 divided by 8. We can split the cube root between these two, numerator and the denominator. If we are multiplying 125 times 8, we could split the cube root for multiplication. But we can't and we do not split a root for addition and subtraction. Okay, so the final answer then is 5, right, over 2. Okay, so I hope you can see, guys, step by step how it is we are able to answer these questions that have to do with substitution of a particular number. And the simplification of what we have relies very heavily on our understanding of bad maths. Brackets, exponents, we do things in that order. Brackets, exponents, division, multiplication, addition, subtraction. We do things in that order, guys. Okay, all right, so this was just a few of the problems there, all right, that I just like extracted from that particular revision exercise based on grade 8 work. Of course, this is not grade 9 yet, guys. This is based on grade 8 work. Okay, yeah, bad maths, guys, is just board maths 2.0. all right, it's board maths 2.0 because the E there tells us that we need to have an awareness after the brackets of the what? Of the exponents, and that's very important. Okay, very important. Exponents and roots need to be taken into consideration. Okay, let's move right along to some simplification questions as well. Simplification questions that really bothered me because, you know, we did some examples yesterday of simplification questions and I thought people had really grasped those simplification questions. The minute people sent me some work of what they had done, I was just shocked with what I was looking at. I was like, hi, guys, what is happening here? What is happening? All right, so let's look at some few simplification questions. Let's start here. Negative 8x cubed minus 2x cubed. We are asked to simplify the following expression. First question, how many terms in the expression? Because that's where we always start. We always check how many terms are in the expression. We need to simplify the expression, so we ask how many terms are in the expression. How many terms? Okay, then everybody says 2. Secondly, are the terms like terms or unlike terms? Because if there are 2 terms, guys, it means that those terms are separated by a plus or a minus sign. So we are dealing with a subtraction of terms here. But the question is, are these like terms? If they are like terms, what do we know about like terms? We know that like terms have the same variable and the same exponent. And therefore, what can we do to them? We can add or subtract like terms. In fact, we can do even more, but it is possible to add and subtract like terms. So let's go here. then what do we do then? Negative 8x cubed minus 2x cubed. All right, what did we say yesterday? When we are adding and subtracting like terms, we do what? We subtract the coefficients. What are the coefficients? Coefficients are the numbers that exist before the variables. In other words, the numbers that are multiplied with the variables. So we keep the variable, so x cubed will stay the same, and then we subtract the coefficients. What's minus 8 minus 2? Minus 8 minus 2 gives us negative 8. Minus 2 gives us what? What's negative 8 minus 2? Negative 10. That is the answer. Okay, simplified, finished. Not 10, negative 10. Good one. Negative 10. Minus 8 minus 2. You see, that's why, guys, I asked the question, how many terms are in the expression? You guys said 2. Therefore, that means these terms are separated by a plus or a minus sign. Then I asked, are they like terms or are they unlike terms? You guys said they are like terms. Therefore, what do I do when I'm adding or subtracting like terms? I keep the variable, because the variable is the same. The variable and its exponent is the same. So I keep it as it is, and then I subtract the coefficient. So therefore, the answer is negative 10x cubed. Very simple, straight to the point, no problem. Let's look at another one. Negative 8x cubed minus 2x cubed. Question: how many terms are in this expression? Answer the question first. Don't answer the question that I'm asking. How many terms are in the expression? Okay, you can see what Riba is saying. Please take note, guys, of the comment section. Please look at what others are saying. You see as well. You are saying what you are saying based on what you know. Others are saying what they are saying based on what they know and believe. What you believe is the truth for you. But the thing is, the minute you are corrected, you must be able to embrace the truth for what it is, not the truth as how you feel it. Please, guys, there's a difference. Okay, so I'm asking how many terms are in this expression, and I'm seeing varying and different answers, which is very, very, very disappointing and hurting. Okay, guys, in this expression, those who said there is one term are 100% correct, and I love you for saying that. You guys are loved by me big time, because it means that you understand the basic fundamentals that have to do with expressions. How many terms are in this expression? There is one term. Why do we say there is one term in this expression? Why do we say that? Why, guys? Can someone who said one term explain to us why did we say there is one term, not two like everybody else is saying? Because a lot of people here are saying there's two terms. Why are we saying one? What is making it that we have one? Okay, I love what Lesego is saying multiplication joins them. Siviwe is also saying brackets group terms to be one. Yes, people, if you look at these brackets mean something. Brackets mean multiply. Brackets mean multiply. Okay. And the thing is, these brackets are joined. They mean multiply in the literal sense. Because they are joined like this, these brackets mean multiply. So this is multiplied with that. And therefore, what does multiplication do? It combines terms. Multiply does not separate terms. It combines terms. Multiplication combines things together. It's like they stick together. Sticks. It's like these terms, they stick together because of multiply. Okay, terms are separated by plus and minus, yes. But here in this case, this negative term and this negative term are joined. They are combined because of the bracket. Brackets mean multiplied. Multiply combines terms. So therefore, that's why we say there's one term. Okay, now, the second question. I hope those people who now have heard me speak, I hope you hear this thing. Don't just hear it. You must internalize it. You must keep it in your heart. It must inform future problems. Because if it does not inform future problems, you are going to have a serious problem with algebra. And you are going to say a lot of curses in your heart about mathematics and how much you hate it because you don't grasp the fundamentals. So now, there's one term. We've talked about brackets, that they mean multiply, and the fact that they combine terms. The second question I want to ask is the following. What is the relationship then between these brackets? You guys said it's multiply. So what does that mean? It means we need to multiply this and that. Last time I told you that when we multiply using what? SNL. And we basically now have uplifted the status of these three letters to not mean what it means on the television screen when we are watching a movie that we shouldn't. We've elevated the status of this S and this N and this L to mean sign, number, letter. When we multiply the signs, we multiply the number, we multiply the letter in that order. So let's go here. Let's go and multiply first, then the signs. Negative times a negative gives us a what, guys? What sign do we get by multiplying a negative and another negative? What do we get? Okay, thank you, Sphio. We get a positive, 100%. We get a positive, no doubt. Okay, then we move on to the number. 8 times 2. Why am I saying 8 times 2? It's because of the bracket. 8 times 2 gives me what? Because we are in the number now. We finished with the sign. 16. Then we move on to the letter. We multiply the letter. X cubed times x cubed. Oh, we are multiplying same bases. Laws of exponent. Exponent law number 1 says what about multiplying same bases? When we are multiplying same bases, we keep the base and we do what to the exponents? We add the exponent. So here, what is the answer? It's x to the power what? X to the power what? Yes, we keep the base, we add the exponents. I love this. I love everybody who's commenting favorably. So it's 16x to the power 6. Done. Okay, done. Thank you, guys. Thank you. I appreciate you. Please, guys, please, let's take note of these little things where these problems are concerned. Here's another one. 3d into minus 5d squared into 6d to the power 4. I'm asking again. How many terms in this expression? Now Riba is like coming in the comment section with with eagerness to answer, because yeah, we know too well what we answered in the beginning, Riba. Now you are answering correct. Okay, how many terms in the expression? You see, a street boy just joined. That is for sure. The reason why street boy is saying there are 3 terms is because he did not listen to what I had said previously with the previous problem. So everybody who has been here is saying one term only. Why are we saying there's one term in this expression? We've explained the reason. Brackets, guys, brackets mean multiply. Multiply does what to terms? It combines terms. So when we are saying how many terms in this expression, we say there's only one term. Multiply combines the terms. Very important. Okay, Mabuto, in question 2, what happened to get 16? Mabuto, brackets, negative 8x to the power 3, brackets, negative 2x to the power 3. Brackets mean multiply. That's what brackets mean in mathematics. These brackets are even combined to show that this and this is multiplied together. So when we multiply, we consider what when we multiply? We consider the sign, how it is multiplied, the number, how it is multiplied, the letter, how it is multiplied. So a negative times a negative gives us a positive answer. 8 times 2 gives us 16. X to the power 3 times x to the power 3, we keep the base. When we are multiplying same bases, we add the exponent. So it's 16x to the power 6. Hope you understand. Now we are here, guys. Okay. Right. So now that we are here, brackets mean multiply. Brackets mean multiply. Brackets mean multiply. You need to get it in here. Brackets mean multiply. We need a song for this so that people can drum it in. All right. It's like, you guys, Chincha Makia, you've got that one, Chincha Makia, you know, like everybody, all these songs. What is this song? Yeah, these many songs that you're saying in the festive season, you've got them down. You know the lyrics. If I play the song, you know it. Okay, so brackets mean multiply. Brackets combine terms. Brackets mean multiply. Brackets combine terms. You see? Yeah, multiply combines the terms. It becomes one. So when we are dealing with this then, guys, it means we are multiplying all of these using what? SNL. So let's go. Positive times a negative is negative times another positive gives us a negative. So we've got a negative sign there. Okay, positive times a negative times a positive. What's a positive times a negative? That gives us a negative, right? Then that negative multiplied by this positive will give us a negative sign. So our sign, we are done with the sign. Let's move on to the next thing. The what? The coefficient number. 3 times 5 times 6. What's 3 times 5? 15. What's 15 times 6? 15. Okay, yes, 15 times 6 gives us 90. So the answer is negative 90. You see, I'm very worried about some people here in this comment section. Okay, I have someone who's asking, why does it give as a positive? Street boy, these are fundamental basics from last year. Negative times a negative is positive. Even number of signs that are the same will give you a positive. Positive times a positive gives you a positive. That's why we say same signs multiplied give us a positive. Then a positive times a negative gives you a negative. So I'm just going to leave that to sort of like settle, but it's very important. So there we go. 3 times 5 times 6. Very good. It's 90. Let's go to D, the ladder. Now we move on to the ladder. D times D squared times D to the power 4. That gives us what? D to the power what? What is that exponent plus that exponent plus that exponent? Remember, we keep the base. We add the exponents whenever we are multiplying same bases. So that gives us D to the power. Thank you, Sima. D to the power 7. Let's say amazing. Okay, all right, let's move on to the next one. Here's another one. 3D brackets minus 5D to the power 3 brackets plus 6D to the power 4. First question, how many terms in the expression? How many terms? So it's counted, that one. Hey, the invisible one. All right? The invisible one. Don't forget that, because if you say 2 plus 4 hour alone, you'll get 6. That one, very important. It's the invisible one. Okay? Maths makes me believe that there's a God, because that one, it's available, it exists. It affects our answer. It's there. We don't see it, but it's there. Okay. So how many terms? You guys said it. It's 2. Very true. Okay. Because you saw that these 2 are combined. This one is alone. Hey, you see now you're catching on, guys. You are catching on. But if we are going to simplify this thing, who do we need to consider? We need to consider this guy, bed mass. We need to consider the bed of mass. Okay, so obviously priority is brackets. So this guy just needs to wait for a while because it's plus. We just need to keep him there. Let's take care of this bracket. Brackets mean multiply. Brackets mean multiply. Let's go. Let's multiply. 3D times negative 5D to the power 3. We multiply using SNL. Positive times a negative, negative. 3 times 5 15. Okay, love it, guys. I love it. I see your comment. I don't know why. I think what you call my comment section is probably fighting. There were some restrictions I might have pulled out in the comment section. That's why your numbers are not appearing. But I see you guys who are typing negative 15. So our sign is sorted. Our number is sorted. The last thing we need now is the letter. And let us not forget Mr. Invisible One that is there. He's always there. So we say d to the power, it's 1 plus 3, which gives us d to the power 4. Ribawone, we do not multiply this one. We are just looking where the brackets are. We are multiplying only that. Because you see, the thing is, yeah, I don't know if some of you see the question I asked at the beginning. I asked how many terms. What did people say? They said there is 1. That's 1 term. Okay. Then there's 2. Okay. So then when we are about to do simplification, we consider who? Bad maths. Brackets, exponents, division, multiplication, addition, and subtraction. Because this is 1, it means we need to first sort out the brackets. Sort out this thing. Because brackets mean what? Multiplication. Multiplication comes before addition. So we are only concerned about these two that are multiplied. That's why we say, what's positive times a negative? Negative. 3 times 5 is 15. D times d to the power 3 gives us 15d to the power 4. Now we have resolved these two brackets. Plus d to the power 4. Now, guys, can you see that our two terms, in actual fact, we said there were 2 terms in the beginning, but our 2 terms were actually made of this combined terms, which actually gives us negative 15d to the power 4. Now, this 6d, to the power 4 minus 15d to the power 4 plus 6d to the power 4. Okay, these are like terms. What did we say about like terms? Can we add or subtract like terms? Yes, we can. So what do we know about when we add and subtract like terms? We keep the variable and its exponent. They are wearing the same jersey, the same uniform, from the same school. So we keep their uniform. What changes? Their coefficient. So all we simply do now is you say negative 15 plus 6. You can even type that in your calculator to confirm the answer, please, guys, because some of you're going to say negative 15 plus 6 and you're going to say it's 21. I don't understand that. That kills me. That just destroys me when kids do that. Okay, so your calculator, if it's there, like really and truly, guys, please don't lose marks simply because you are careless and you don't care about the numbers being added. Okay, how many years have we been adding and subtracting integers now? We've been doing addition and subtraction of integers. We did it last year in grade 8. Okay, you are now in grade 9. You know what's sad is to see even matriculants adding and subtracting like terms incorrectly. Like it's so hurting, man, because you think about the fact that this person has been doing maths for the past I don't know how many years, but then they are in matric and they don't add and subtract like terms correctly. So please, my beautiful grade 9 maths gamers, you need to make sure that take your calculator and verify the answer. Put in the negative 15, add the 6. You will see what you get. Okay, please, guys, please. So our answer is negative 9 d to the power 4. And our marks in the bag, right? In the bag. So I really want to reiterate the importance of making sure that we do those things the way that we're supposed to do them. Here's another one. Question that I ask all the time. Ask it for me. The first question that we always ask when we are dealing with an expression. You can see people are giving the answers. How many terms are in the expression? Very good. Very good. You see, I love you guys. You guys are learning very quick. There's one term. And why is there one term? Brackets, exponent, dot, meaning multiply, brackets, exponent, exponent externally. So this is one term. But we must look at the individual brackets. Dot means multiply, definitely remember. So 2x to the power 7, the whole thing squared. Now, once again, we need to think of who? BEDMAS. Yes, dot means multiply, guys, just like the brackets. So BEDMAS. So we look at this bracket, we look at the exponent, and then we say brackets followed by exponents. So this guy, we need to exponent apply. This guy, we also need to exponent apply. This exponent 2 only covers 2x to the power 7. This exponent 7 is around x squared. All right. So we remember in exponents, there was that law that said a to the power m, b to the power n raised to the power p. That can actually be written as a to the power m times p, b to the power n times p. That is when the relationship between the bases is multiply and each base is different, raised to a different exponent. So in the same way, this exponent will be applied to the what? To the sign, to the number, to the letter. And that's very important. This exponent, we're going to apply it to the sign. There's a positive sign here, but obviously an even exponent applied to a positive sign just keeps that sign positive. We apply the exponent to the number 2, that gives us 2 to the power 2. We apply the even exponent to the 7. What happens to the 7 and the 2? The 7 and the 2 get multiplied, guys. I want to actually do that. We distribute the exponent by multiplication. Okay, there was someone that I was marking, you know, in the grade 9 group that basically said that we add. Someone was consistently saying from all the problems that had to do with this, they would say 7 plus 2. Please, guys, please make sure that we understand that the exponents are multiplied for when they are external to the bracket. They are not added. Please. That is a huge misconception. Okay? No, we don't, Junior. You see, and these are the things, guys, that you need to make sure that you are clear about now. I am clarifying things for you on a TikTok live, watched by 100 and something people right now, currently live. There's many kids that are doing the same thing, the same errors. They've believed a lie for the longest time, and they keep on lying to themselves. 7 plus 2, 7 plus 2. Some of you have ingrained this thing, this idea, this false idea. We need to fix the false idea now. We need to actually embrace the truth and see, oh, when there's a bracket, we distribute the exponent by multiplication. Please, guys, I beg you, all right? No. We are not factorizing here, guys. We are not factorizing later. This is simplification, okay? Yeah, this is simplification. So we apply the exponent there, 2 squared, x to the power 7 times 2. You apply the exponent as well here, x to the power 2 times 7. So I'm just going to now simplify. 2 squared is 4. X to the power, what's 7 times 2? It's 14. X to the power 14. Okay, bracket has been removed. The dot is still there. The dot means what? Multiply. Now we can multiply 4x to the power 14 times the x to the power 14. And when we do that, we apply what? SNL, because when we multiply, guys, we are always applying multiplication of the sign, multiplication of the number, multiplication of the letter. This is multiplication of 4x to the power 14 times x to the power 14. Okay, yeah. So now when we multiply, this here is positive. The x to the power 14 is positive, so that leaves us with a positive sign. We move on to the 4. The coefficient of x to the power 14 that you don't see there is 1. What's 4 times 1? It's 4. The number has been sorted out. Then lastly, we take care of the letter. x to the power 14 times another x to the power 14. That gives us x to the power 14 plus 14. Because we keep the base, we add the exponent. The answer is 4x to the power 28. People, I beg you, we need to have great sensitivity to what we are seeing in our expression. You see, even here, we still have one term. This term, yes, is a like term to this one, but what is happening between these two? It's multiplication that is happening. So when we are multiplying, we apply SNL. We multiply the sign, we multiply the numbers, we multiply the letters. And when we multiply the letters, we remember our exponents, we keep the base, we add the exponent, we get an answer of 4x to the power 28. Please, guys, these questions and problems are so nice and so delicious when someone knows their rules. If you know your rules, my goodness, there should be no reason why we should be losing marks here. Not even. Let me give you another one. Look at this one. Look at this question. Right, look at this one. Look at this one. Look at this guy. Look at him. Look at this one. What is the first question? You see, look at this, Junior. Can the 4x and the power 8 further divided each side by 4? No, Junior, no, Junior, no. Okay. Yeah, I think yeah. So how many terms, guys? You are 100% spot on. I love everybody's answering right. There are 2 terms in the expression. This bracket houses, this is the one term. The minus sign separates, this is another term. All right? So there are 2 terms. So that means we need to deal with this term and we need to deal with this term, because in each one, what can we see? We can see a bracket and a exponent. So bad maths needs to be applied in each term. So let's look at this one first and apply brackets. Okay, there's the brackets there. What's inside is one term. So we are ready now to say exponents. Apply the exponent. What do we do to the exponent? We distribute the exponent to each base for each exponent. So the exponent needs to first be applied, distributed. Apply the sign first. We apply the exponent to the sign. It's positive, obviously it stays positive. We apply the exponent to the number. That gives us 2 to the power 2. And then we apply the exponent to the letter, the exponent of the letter, which is 7 times 2. So I'm just going to go straight to the answer. It's x to the power 14. Okay? All right. Then minus. Same thing, the exponent 7. It's an odd exponent. We apply it to the sign that is inside the bracket, which is positive, which stays positive. Then we apply that exponent to the variable and its exponent. So it's x to the power 14. Then what we do is we say 4x to the power 14, negative times a positive. Now we can apply the negative sign and remove the bracket. It's x to the power 14. Now, how many terms do we have in the expression at the moment? How many terms do we have in the expression at the moment? I hope you guys can see the terms, the number of terms we have. It's 2 terms. And these terms, are they like or are they unlike terms? Because there is subtraction for the 2 terms. Are they like terms or are they unlike terms? So I'm sure you can see these are like. They are like terms. What makes terms like? Like terms are like because they have the same variable and the same exponent. So that means when we are adding and subtracting like terms, we know what to do. We keep the variable and its exponent. So that means x to the power 14 is still there. Our school jersey and our uniform is still intact because we are one. We are united as like terms by the same uniform. Then what do? we subtract the coefficients. What is 4 minus the coefficient that is there that you can't see is 1. 4 minus 1 gives you 3. Very good, 12. Very good, Kagiso. Sviwe, sweet. Right? Okay. Not that bad, guys. Not too shabby, hey? Not too shabby, Nigis. I hope you can see it's not too shabby, guys. Not too shabby at all. Okay. I'm gonna give you this one for you guys to tussle with. Okay. Okay, and as soon as you get done, you write, you please do it step by step on your own in your space. You do this one alone in your space. Then when you are done, you are completely done, you are more than welcome to type your answer in the comment section, and we'll take it from there. So that is the question. Negative 2x squared to the power 3 minus brackets minus 2x to the power brackets to the power 4. I'm on 12. It's not too much. You see, that's the thing. When you are teaching people and they are not in the same place, maybe for you it's easy, all right? But the thing is, for some people it's not easy. It's difficult. So it's good when I'm able to actually do a few, because for some people that's how they are able to actually hammer the concept in when they see it being done, all right, over and over again. So let's do this one. I'm not doing university maths, I'm doing high school maths. It's all high school maths here, grade 8 to 12. Okay, so I'm giving you some time to do this, guys. Some time. But it looks the same when you explain it better, is it? Just send me a message on the side, Marachadi. Send me a message on the side in the inbox, and then we can chat further about the specifics of this, what you are doing at university, and see if I can assist with that, if feasible, if possible. You're welcome. You should stop being lost. You like being lost. I've seen that in the comment section. You always seem to say, I'm lost, I'm lost, I'm lost. Just not so long ago, we did problems that were like this, and you were found. So you need to find yourself in this problem. Be found. Don't be lost. Don't like this idea of being lost. Don't allow your mind to be always on this mode of being lost, because whatever you say, you'll tend to believe it the most, right? So don't allow that to happen too often. Okay, so is it coming nicely, guys? Is it coming on nicely? Is it coming on sweetly? Yes, I do, Seipe. I do. Just contact me on the side, like I said. Right? There are times when I do I do a live lesson like this on TikTok, but then I just invite you as a guest, and I just deal with your problem, your specified problems, but then everybody else joins in and checks out whatever we are doing. But like I said, that obviously does not come just free. It's obviously comes at a price. So are we coming, guys? Are we coming? Geleto, I see what you said you got there. Geleto Pros got that. I see. Street Boy is saying minus 4x to the power 2. Oh, we'll be so shocked when we do the correction. Okay. Okay, I'm going to give you 2 additional minutes, guys, to finish up, and then we'll do the correction. Okay, I'll take it up until 8 o'clock this session, and then I'll end the live at 8 o'clock, guys. I need to get the grade 10s in here. I need to do corrections for what I did with them, and then I need to get the grade 11s in here at 9, so we need to end this at 8. Okay, I see what everybody, my comment doesn't want to be posted. Oh, shame, man. Why? I wonder why. I'm sorry about that. The fact that your comment doesn't want to be posted. I know you, Lesejo, you probably have the answer. That's why as well. Maybe that's the thing. Can't have the correct answer being posted for people to see. That's probably why. That's why the thing is fighting. Okay. With just 30 seconds to go, guys, until I basically go ahead and do the correction for all of us to see. But maybe, let's say you can indicate in the comment section. Indicate for me in the comment section. Has anyone posted your answer? Now you got it right and it's not posting it. That's funny. Keletso and Lesejo are having a tough time posting. No, guys, it's fine. All right. You'll just verify and confirm with me when I do it, okay? All right, so no one has actually commented the right answer, and probably all the people that are trying to comment the right answer, they are having a hard time commenting and commenting. Maybe it's because we don't have to see that one. But when you know it, you know it. Okay, first question, how many terms are in the expression? The typical famous question that this maths is a game host guy always asks. How many terms are in the expression? Guys, I'm sure you can see there are 2 beautiful terms in the expression. Then, like I said, each term needs us to apply what? The bed of mess. So there's a bracket with its exponent. Okay, funny, no problem, man. Just hang tight, hang on to your comment, hang on to your answer. You'll just comment for me in the comment section. Yeah, so minus 2x squared, the whole thing to the power 3. So this is an odd exponent. An odd exponent applied to a negative sign. What does it do? Does it change the sign or does it keep the sign? Because remember, we said that we distribute the exponent for the sign, for the number, for the letter. So this odd exponent, what does it do to a negative sign? Very good. It keeps the negative sign. Kache, so you're amazing. Okay, you're amazing. Then that's done for the sign. Now we apply the odd exponent to the number. So to the number, this is 2 to the power. Obviously, we have a 1 there, 1 times 3, so it's 2 to the power 3. Then to the variable or to the letter, it's going to be x to the power, it's 2 times 3, which is 6. Okay? Minus. Let's focus on the exponent for the second term. And the minus sign can just wait there. The even exponent to the negative sign does what? The even exponent to the negative sign, SNL. The even exponent to the negative sign does what to the negative sign? The even exponent changes it. Very good. To what? To positive. Okay, thank you. So we know almost that positive sign is an invisible positive. Whether you write it down or you don't, it's there. 2 to the power 4, because it's 1 times 4. Then x to the power 1 times 4, that's also 4. Bracket closed. Then negative, what's 2 to the power 3? it's 8x to the power 6, minus 2 to the power 4 is 16, guys. Okay, 16, negative 16x to the power 4. All right, how many terms do we have in the expression? There are 2. Are these like or unlike terms? Like or unlike, guys? Are these like or unlike terms? Are these like or unlike terms? Thank you, unlike life with Ntabi. Life with Tabi, Lesejo, Ribawona, everybody that's saying unlike. These are unlike terms. Can we add or subtract unlike terms? No, we cannot add or subtract unlike terms. This is a rule I mentioned yesterday when we were doing the live. This is a rule you learned in grade 8. This is a rule you should know. What makes these terms unlike? It's the variable, it's the exponent. The variables are the same, yes, but their exponents are different. So yes, we end there. You can't go any further. This is like you saying, this is like you trying to add the bananas and potatoes. No, bananas and potatoes, they stay apart, guys. Bananas, if you have 8 bananas and you have 3 potatoes, it's 8 bananas and 3 potatoes. That's what it is. They remain separate and apart. Okay? Okay, I hope you understand that. Okay? Yeah. So everybody who is commenting otherwise, there are people here that are, you see, some of you have been programmed. Like I said, some of you believe things that are wrong. And there are people, for instance, I'm seeing in the comment section that are insisting, Olga, for instance, is saying negative 8x to the power 10. You see? Olga is saying negative 8x to the power 10. He's saying that's the answer. Guys, guys, please, 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 okay? I plead with you. Plead with you. We leave the answer as it is. How did you get the 8? What's 2 to the power 3? What's 2 to the power 3? Remember, 2 to the power 3 means 2 times 2 times 2. What's 2 to the power 3? It's 2 times 2 times 2. What's 2 times 2 times 2? 2 times 2 is 4. 4 times 2 is 8. That's where the 8 comes from. And it's negative. Okay? And all the people that are saying, take out a common factor. No, guys, no, 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 no. We've been asked here to simplify. Okay? We don't take out a common factor. This is where we end. We end right here. It's done. We are finished. This question didn't say factorize. No. All right? In fact, it's still early days to be saying that because we are doing revision, grade 8 revision. How does the exponent change the sign? You see, this is another thing. And the people I'm going to tell you now, these are the things, the little things that kill. I'm saying to you, if the exponent, and I explained this yesterday, if the exponent is an even number, and you have a negative sign, an even exponent only does one thing to a negative sign. It changes it to positive. But an odd exponent keeps a negative sign. All right? Yeah. So those are important things. These are fundamental basics that I emphasized even yesterday. Okay. Yeah. So hopefully you understand that. Okay. Yeah. Okay. Keletso. The demand, Keletso, the demand. Right. So hopefully we saw that. Let me just let's see. I want to change the card here a bit, and let's do this. No, guys. You see, some of you are coming into the comment section and you don't understand what has been happening and what is happening now. Okay? Yeah, so we are still in the beginning stages, all right? I'm revising grade 8. We are going to transition into the actual grade 9 syllabus. But in order for the grade 9 syllabus to make nice, beautiful sense, this needs to be clear. If you're not clear here, I'm nice, foresee problems. Okay? So I'm having grade 11. I'll do at 9, Gladys. I'll do grade 11 at 9 p.m. because at 8 p.m. 8 p.m. I'm going to do grade 10. Okay. So 3 into a squared to the power 3 times brackets 3a squared to the power 3. Right? So I'm gonna give you 2 minutes for this one, not even more than 2 minutes, 2 minutes to do this one. Then I'm gonna do a correction. Then I have a few others that I want us to do that are not as simplistic as this. Okay. Okay. And guys, the whole live session is dictated by my network, my network connection. My network nowadays is basically not obeying, me at all. It chooses when to be on, it chooses when to be off. So yeah, I can never tell. That's why I can never give you a specific time when I'm doing lives. You just need to catch me. But what I do is that with all the live sessions that I do, I post the videos onto my YouTube channel. So you can always go there to my YouTube channel and rewatch any of the sessions that I've done here, because I upload them onto the YouTube channel. Go to my link in the bio, it's there. You can check out. For instance, I've uploaded the 2 lessons that I covered yesterday. Sorry, the previous days for the grade 9s. I've uploaded them onto the YouTube channel. So you can go watch those sessions and check out the basic things that we covered. The explanation for why we say there's 2 terms, the explanation why for like terms what do we do for like terms, what we don't do for unlike terms, what we do for multiplication, how do we identify that there are 2 terms instead of 1, and all of that stuff. Okay, so go and check it out, the YouTube channel. The link is in my bio. Previous grade 12 lessons that I've done as well in term 1, like for your sequence and series functions for grade 12, they are also there, like all the sessions that I've done. Okay, all right, 2 minutes is up, guys. 2 minutes is up. I see the answers. Okay, I see the answers, and I see you guys. I sees you. There's some of you that I just love, I must say. Like, some of you I just love. Like, I feel like there's people here that have been, some of you would know because I teach you at school. I have my learners, some of my learners from school are actually here on the comment section. And I can see when they comment, I see the answers that they give, and I can see that they are with me. Like, I mean, they are really walking with me, and I love the fact that they are aligning to the things that I've been saying. Then there's some of you who have picked up with the live sessions, and you've been joining my live sessions. Some of you were here during December and stuff, so I like that. Let's keep it up. Yeah, keep up the good work. Okay, let's go. There's 3. There's a squared. So how many terms are there in total? There is one beautiful term, because the relationship is multiply, so there's 1 beautiful term. So we need to sort out this one with the bracket, and then we need to sort out this here with the bracket. Okay, so for this one, what do we get? We get 3. This is a to the power, what's 2 times 3? 6, right? We go to this bracket. We apply the exponent to the sign, it will be positive. We apply the exponent to the number, it will be 3 to the power 3. We apply the exponent to the letter's exponent, we get a to the power 6. Okay, so I can see them giving us a mark here and giving us a mark there, of some sort. Now we can multiply the 3 with the a to the power 6, because Brackets have been done, exponents have been done, division, now multiplication can happen. Freely, it can happen. You see, we couldn't multiply this 3 with this a squared, but the exponent hasn't been taken care of. That's why we start taking care of the exponent, the bracket, then the exponent, then later on the multiplication. So now we can say 3a to the power 6. 3 to the power 3 is 27a to the power 6. How many terms? Still one term. What are we doing? We are multiplying the terms. So when we multiply, we use SNL. Positive times a positive is positive. 3 times 27 is 81. Sign number done. Letter a to the power. Bases are the same. We are multiplying. What do we do to the exponents? We add them. So it's a to the power 12. So 100% well done to those people that basically said 81a to the power 12. You guys are amazing. You're phenomenal. You are just amazing people. That is for sure. Okay. Moving right along. Do you still remember this? Simplify. We are still dealing with simplify. Yes, you can do too. You can change the dot to multiply. Okay, remember dot, multiply, brackets, they all mean multiply, so it doesn't matter. Okay, whether you write a dot, whether you write multiply, whether you write dot or multiply or brackets, it's all one and the same thing. Okay. How many terms are in this expression? Let's see people. How many terms are in this expression? This is 3 brackets a minus b close brackets minus 2 brackets 2a minus b close brackets. How many terms are in this expression? Simaru Siviwe, you're amazing. Adang, you're amazing. Life with Ntabi, we need to review your answer. You're saying there are 3 terms in Ntabi. Why are you saying there's 3 in Ntabi? Ntabi, why are you saying there's 3? Ntabi, 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 why are you saying there are 3? Khotatso, you are saying there's 4. Now that is very heartbreaking. Ha! Guys, right? So this goes back. Please, I encourage you to go and watch my previous videos of you know, the work that I've covered so far for this grade 9 algebraic expressions. I've posted the 2 videos in my YouTube channel. Go and watch the very first video. We established how we count the number of terms and what combines terms, what separates terms. So yes, those who said 2 terms, you are 100% correct. There are 2 terms in this expression. Why? The brackets combine the terms. So this is 1 term. Brackets combine. This bracket, what it does to this a minus b is it makes it 1. And then this 3 and this bracket have a relationship of multiply. So this becomes 1 term. Also, this is another term. So this is my 2nd term. And this minus separates this 1 and 2 term. Are you with me, guys? Are you with me? Are you with me? Are we going together, guys? Is everybody with me? Why there's 2 terms? All right. Then listen, Kengo. Listen to this part. Now that we have this 1 term and there's a bracket, there's something else that we must note here. This here is what we call a monomial. 3 is a monomial. This bracket is also going to be regarded as actually a monomial, but inside the bracket, how many terms are inside? This is what I want to ask you guys. How many terms are inside this bracket? Tell me, inside the bracket, how many terms do you have here? How many terms are inside the bracket? Thank you, Atang. Thank you, Keletso. Thank you, Kat. Thank you, Ribawona. Thank you, Clutch Picks. I know Clutch Picks, you know, no Clutch Picks and Ribawona, you're not telling me the right thing. I asked how many terms are inside the bracket. There are 2 terms, guys. The bracket itself makes these 2 terms 1, but inside the bracket, this is like we are excluding the bracket. Inside we have 2 terms, all right? No problem, Ribon, no problem. So there are 2 terms inside. So this here is what we call a binomial. The inside of the bracket is what we call a binomial. So there is something that we usually use whenever we have a monomial binomial relationship. We use the distributive what? Law. The distributive law. You learned about the distributive law when you were learning about the properties of numbers. Okay? The properties of numbers, whole numbers, the distributive law. So what we do then with this monomial multiplied by this binomial is we distribute the 3 by multiplication to the a. We distribute the 3 by multiplication to the negative b for this term. Why? Because there's a monomial and a binomial multiplied together. Are you with me? So when we apply the distributive law, we apply using, hey, this guy is very famous, this guy. The following movie contains scenes, I'm just kidding. The following maths problem contains sign, number, letters. Okay? So please, when we distribute using sign, number, letter. So let's go. 3 times AB. So we start positive times a positive, positive. 3 times 1, 3. The A combined with the 3 gives you 3A. 3 times negative B. Positive times a negative, negative. 3 times, there's a coefficient of 1, 3. The B is the letter next to the 3. Done. Now we distribute the negative 2 also to these, because this is a monomial by a binomial inside the bracket. Are you with me? So the negative 2, please guys, when we multiply, the 2 is negative. So when we multiply, we must take the negative and multiply with this positive. What's a negative times a positive? Negative. Sign is done. What's 2 times 2? The number? 4. The number is done. Letter A next door combined. Then we say negative 2 times negative B. Sign, number, letter. Sign, negative times a negative, positive. 2 times the 1, 2. The B next door. 100%. And when you have this so nicely done, there's this beautiful pen that tends to be your friend, you know. This beautiful pen tends to be your friend when things like this happen. This beautiful pen, it tends to be your friend. Okay, now we just arrange and take like terms. 3a and minus 4a are like terms next to each other. You see the sign of 3, it was positive. You see the sign of negative 4a, it was negative. It's still like that. Negative 3b plus 2b. Okay, then final answer, we add like terms. This guy is a like term, same uniform. The uniform stays the same. What's 3 minus 4? Negative 1. B, negative 3b plus 2b. The uniform is B. Negative 3 plus 2, negative 1. So it's negative 1b. So our final answer, it's like saying negative A, negative B. That is our answer. Thank you. Right. Okay, are we good? So we need to use the DL using SNL. DL means distributive law using SNL. Then like terms, we collect group like terms. Very important to group the like terms. Okay, and then after that we simplify and get the answer. Okay, making of sense? Sense making? Yes, this is grade 8 revision it's grade 8 revision, but it's the foundation for our grade 9s. I'm dealing with the grade 9s here, but I'm allowing them to do some grade 8 revision first, so that by the time we move on to some grade 9 content, they are fine. You know, it's very important. So even you as a grade 8 learner, you must make sure that you are solid. If you are busy with grade 8, don't take things for granted. Don't be like these learners that are here, some of them who are making mistakes that are silly. You know, when you must be solid with the basics. Okay. Okay, I want to you want to take a screenshot. There it is. You want to take a screenshot of this. Yes, it's the same name. Maths is a game. This is called Maths is a Game 5 to 7. Okay, all right, look at this problem. Negative into x squared minus 5x minus 6 close brackets minus 2x. My question is, how many terms are in this expression? Let's start there. How many terms? Negative into x squared minus 5x minus 6 close brackets minus 2x. Clutch picks, you said 2. Speleze says 2. Skeleto says 2, Funny says 2, Sima says 2, Spirit says 2, Rewan says 2, Seiko says 2. Okay, we are 2 everywhere. Right. Now, since there's 2 terms, what do you notice though? There's a minus sign outside this bracket. And how many terms are inside this bracket? There are 3 terms. So in essence, we have a -1, but there's a trinomial, and then there's a term that's just a standalone term here. Okay, so once again, distributive law. Who is getting distributed? The negative sign is getting distributed to the 3 terms. How? By multiplication using what? SNL. So let's go. Let's apply SNL. Let's see. Negative times x squared, and negative times a positive, negative x squared. Negative times negative 5x, and negative times a negative, positive 5x. Negative times a negative 6, a positive 6. Bracket has been removed by distribution, and then this negative 2x, which is standing there. So then what's left now? How many terms do we have in the expression? We now have 4 terms. But do we see anything there? Are there any, because usually after we distribute using SNL, we check, are there any like terms? Are there any like terms in my expression? Because we need to take care of those. Plus 5x minus 2x, bring those close together like the twins they are. We bring these close together like the friends they are with the same uniform. The uniform is the same. So finally we get negative x squared plus 5x minus 2x. We keep the variable. We add, subtract the coefficients. What's 5 minus 2? Plus 3. Plus 6. Done. Can we do anything else? No, there are unlike terms. We can't do anything further. We stop right there. That's as far as we can simplify. Okay. Can you do this one, guys, as a parting, a farewell problem? No. Sipheleze Jitana. I don't know what grade you are in. This is grade 9. And in grade 9, at the moment, we are doing grade 8 revision. And these are simplify questions. The simplification question only requires us to basically simplify the expression. We did not say factorize. Okay? We did not say factorize the expression. So therefore, yeah, and these learners have not as of yet covered that topic because we are going there, but we are doing a build up to go there. Okay, guys, I don't know how you guys are receiving my connection that side. It's just that it's changed. My connection has changed from good to unstable. So if you do experience that my network is not as great, please let me know in the comment section. Why is it +3 not -3? That's the question that someone was asking. 5, that is positive, -2. What's positive 5 -2? That's a question you need to ask yourself. And really and truly, that question, the sooner you answer it, then maybe you will see whether that 3 should be positive or negative. Okay, the 5x is positive and the -2 is negative. So 5 - 2, just practically speaking, if you keep the variable x, you add and subtract the coefficient. Yeah, so we have 5 - 2. What's 5 - 2? It's 3. Okay. Yeah, guys, my network, you see, again, that's why I was saying my network does funny things when it does. Currently, what I see on my screen is I'm having unstable connection. How's the network, guys? Let me know in the comment section. Yeah, we take the sign of the bigger coefficient, definitely. We always do for different signs. For different signs, it's like you switch off the signs, you say big minus small, and then you take the sign of the bigger number. Yes, this is for grade 9. Right, and I wanted you guys to do this one. So you always ask yourself the famous question, how many terms in the expression? You start there. How many terms in the expression? Once you answer that question, the rest is fine. Okay. How many terms are in the expression? If you are skilled, you will know that there are this number of terms. But if you are not skilled, then you will butcher the number of terms, and you will mistake the number of terms and how many they are. Okay, and it's very shocking to see the comments about the number of terms. People are saying there's 2. Guys, how can you say such? No. Factorize for what? We are simplifying here. Guys, people are insisting they want to do things that they need not be doing. Okay, there are how many terms? There's one term here, guys. There's one term. There's a negative there, right? But the negative is multiplied because brackets mean multiply. So that means, in other words, there is this bracket and this one as well. There's a relationship of minus, multiply. So basically there's one term, because what do brackets do? They combine terms. Brackets combine. Brackets mean multiply, and multiply combines terms. Okay. This here expression is different from this one. You know how? Because this one shows a separate term, but this one, because of the bracket, this bracket combines because of multiply. The relationship of multiply makes the combined terms to be 1. See? Yeah. And therefore, the way you do the question will differ as a result. The way you do the questions will differ. Okay. So think about this practically then. You can take, how many brackets are there? So there's this bracket 1, and then there's this bracket, okay? And these two brackets are multiplied, okay? It makes this and this multiplied because of the brackets, okay? So what we do then, guys, here, you see this negative sign? You need to distribute it. And you can distribute the negative sign to just this bracket. After you get whatever answer, then you can go ahead and take this negative 2x and distribute it as well. There's many ways of doing this. You could either multiply this negative and this negative 2x to get a positive 2x. Then you take the positive 2x and distribute it into the 3 terms. Or you could take this negative sign, distribute it to the 3 terms, and after you are done, take this negative 2x, distribute it into what you will have got after distributing the negative sign. At the end of the day, you will get the same answer. Why is this possible? Because with multiplication, we know that multiplication is commutative. It's commutative. Multiplication, guys, is commutative. What do we mean by multiplication being commutative? It means the order in which you choose to go about multiplying the numbers doesn't matter, or multiplying what you have doesn't really matter. So what I'm saying, you can take this negative and distribute it for the first 3 terms. Then after you are done, you take the negative 2x and distribute it for the 3 terms. Or you could take this negative, multiply it with this negative 2x, get your answer in the bracket, and then take this and distribute it to the 3 terms. Either way, it will work. So I'm going to do both approaches so that you can see it works either way. Take this negative sign, distribute it, but after you distribute it, you're not going to remove the bracket because there's this bracket, okay, which still means multiply for these 3 terms. Let's take the negative and distribute it. We get negative x squared plus 5x plus 6. Okay, but we keep the bracket after distributing because the relationship of these 3 terms is multiply for this term, for this particular base. So it's very important for this particular bracket. Okay, now we can take this negative 2x and distribute it to all 3 terms, all of them. And remember, sign, number, letter whenever we do that. So what's negative times a negative? That gives us a positive. And then what's 2 times the 1? That gives us 2x. 2x what? X to the power 2 times x. Bases are the same, so we keep the base, we add the exponent. We get 2x to the power 3. Okay, I repeat. Negative times a negative, positive. 2 times a coefficient is 1, gives you 2. X times x squared, we keep the base. There's an exponent 2, there's an invisible exponent 1, so that gives us x to the power 2 plus 1 gives you 3. We are done with the first term. We take the same negative 2x, we distribute it to positive 5x. Negative times a positive, negative. 2 times 5, 10. X times x. Keep the base, we add the exponents, it's x squared. Then this term times this one. Negative times a negative, negative times a positive, negative. 2 times 6, 12. X next door. Done. Done. So this is how we would go about attempting this question. This is one way in which you could go about answering this question. Like I said, you have these three things multiplied, this negative sign with this trinomial with this monomial. Okay, so what I said is you can take this negative sign, multiply with this alone. So you take the negative sign, you multiply with x squared, you get negative x squared. Take the negative sign, multiply with negative 5x, you get positive 5x. You take the negative sign, you multiply by negative 6, you get positive 6. The negative sign changes everything, every sign inside this bracket. Okay? But then you keep the bracket. Why? Because this negative 2x is multiplied with these three terms still. So you have to retain this bracket. You keep it. It does not go anywhere. Then you have negative 2x here. Now you still have the brackets, which mean what? Multiply. Monomial multiplied by a trinomial. So you need to distribute this negative 2x to all three terms again. So let's distribute. Negative 2x times negative x squared. Apply sign number let. What's negative times a negative? That gives us a positive, right? So that's why we have positive. 2 times 1, there's a 1 here that you don't see, gives us 2. X times x to the power 2, the bases are the same. So we keep the base, we add these exponents. 2 plus 1 gives you 3. We are done distributing negative 2x to negative x squared. Now we take negative 2x, we distribute it to positive 5x. Negative times a positive gives you a negative. 2 times 5 gives you 10. X times x, bases are the same. We keep the base, we add the exponents. There's an invisible 1 here, there's an invisible 1 there, we get x squared. Then lastly, negative 2x multiplied by positive 6, and negative times a positive is a negative. 2 times 6 is 12. X next door to the negative 12. And that is our answer. 2x cubed minus 10x squared minus 12x. Finished. Okay. I don't know if there's any further questions. Okay, very, very important. So if there's questions that people have, please, why we not say minus times minus 2x? Why we not say what? Minus. Oh, you mean why don't we distribute all the way? No, 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 no. Okay. All right. What you're asking, right? I mean, you could do that. You could. Okay, you could. It's just that I am trying to break it up so that for me, I'm able to see what I've done. Okay. Okay. Yeah. And remember, this is negative and this is a bracket. So I'm trying to distribute this negative to just that. This is the same thing as saying 2 times 3. If I say 2 times 3 and I say 6, I mean, there's no problem in saying 2 times 3 is 6, and then when I get the 6, I say 6 times 4 is 24. Okay? All right. So, yeah. Or if I said 2 times 4 instead, and I said it's 8, and then 8 times the 3 still gives me 24. That's why I was saying, guys, the order doesn't matter, you know, the order. So for instance here, what I've done is I've taken the negative and I've multiplied with the trinomial first so that I can get my answer for that. Then I take the monomial again and I distribute it to my trinomial. That is just for me, all right? That's just for easiness for me as I do the problem, okay? Hope that makes sense. And I hope that's understandable. Someone else doing the same problem could have decided maybe to do the following: rearrange the terms. easily. Okay, this minus, the minus is still there. The negative 2x, yeah, you can. Like I said, you can. Like I said, for me, it's just the easiness for me, all right? But if it works for you, then it's fine. You can do that. So like I said, you could rearrange this because like I said, multiplication is commutative. The thing is, the order in which these are placed doesn't really matter because it's multiplication throughout. So I could say negative, bring this minus 2x closer, and then I place the trinomial term last. We could do that, okay? Then we could say negative 2 times this negative 2x. That gives me positive 2x. And then all I need to do is distribute the what? The 2x to the trinomial. And I mean, that makes life very easy because all I did is I first said negative times negative 2, that gives me positive 2x. And then after that, I can take this 2x and distribute it to the 3 terms. All right, so 2x times 2x squared will give me that 2x cubed. Then the 2x times negative 5x will give me that negative 10x squared. And then the 2x times the negative 6 will give me that negative 12x. Still, same answer, just the approach slightly different, okay? Hence even the other approach that you've mentioned in the comment section, okay? All of these are just different ways of looking at the same problem, but at the end of the day, we are able to get the same answer. So whatever seems to be a bit easier for you as far as approach is concerned, go for it. So I would really honestly, because I know that multiplication is commutative, I would probably rearrange my multiplication first, and then I would do it, okay? Yes, Ntutu, you can switch the x. Like I said, guys, this whole thing rests in the idea of the fact that multiplication is commutative. The order doesn't matter. So for instance, 2 times 3 times 4 can be written as 4 times 3 times 2, or you can write it as 2 times 3 times 4, or 2 times 4 times 3. At the end of the day, it's still the same thing, all right? So here I'm just having a progressive number of terms multiplied to each other, you see? So the negative, you would say that's like my monomial, but it's a sign alone. That's a monomial, but with a sign, number, and variable. This is a trinomial. It has 3 separate terms. So it's always nice to just sort this out. Negative times negative 2x, I get positive 2x. Then I take that 2x and I distribute it in, and it makes life very easy. Instead of this complicated sort of like approach where, you know, it makes life very difficult. So rearranging is fine. You can do that. Why does it become to the power 3 instead of to the power 2? That has to do with the fact that whenever we are multiplying bases that are the same, the law of exponents says if you are multiplying same bases, you keep that base, which is a, you add the exponents. So here there's an exponent 1. For this base, there's an exponent 2. We are multiplying. These are bases that are the same. So when we multiply, we keep the base x, we add the exponent. So it's x to the power 3. That's why it's not x to the power 2. Okay, all right, I think we, I know this is like really going over the time that I had stipulated, but yeah, you see, sometimes guys, I'm not driven by just myself, but sometimes it's like this because of need. I want to give you this. I want to see 2p as opposed Okay, can you do these, guys? Simplify. Take them down first. I want you to do this 1, 2, and 3 for me, if you can, please. Now, take it down and do it. Simplify. These are all simplified questions. And this is like on a concluding note. And then I guess the grade 10s I won't be seeing. I'll have to just postpone their lesson to tomorrow or something. I hope you guys have buckled down and you're doing them, these problems that I'm just writing down here. Yes, please do screenshot, but I want you guys to do these problems as in like now. 2p minus 4p into 2p squared minus 1. Then this one, 2p minus 4p into 2p squared minus 1. Number 3, there it is. Minus 3x into x cubed minus 2x squared minus 4x, close the bracket, minus x squared into 2x squared minus 3x plus 1. Then here we have some division. Okay, minus 5m to the power 3 n to the power 4, the whole thing squared over negative 5 into mn squared to the power 2. Okay, there is number 1. 2p minus 4p in brackets, and then in the second bracket 2p squared minus 1. And there's number 5, 9a squared b minus 18ab squared over negative 3ab. That's number 5. Okay, and then I'm conjuring up some more here with square roots and roots, and we'll call it the last bit. And then I guess I'll end my live with you guys at 9 o'clock, because I do want to actually look through these. And then yeah, because when I continue guys with the grade 9, the next lesson, this is a place I will have passed and gone. Okay, so if you guys will still be here, you know, still hung up with these problems and still having problems with these kinds of problems, then it's not my problem, it's your problem. And you guys need to sort out your problems, because your problems are going to affect other problems and there'll be more problems. So I hope you guys are doing these. You are doing them now as we speak. Yeah, it's what I call algebraic expression maths marathon. The tired get weary and they tap out, they leave the life. The strong, they hold on for dear life until the end. Can't see. Okay, what can't you see specifically? Number 3, because this was number 3, negative 3x brackets x cubed minus 2x squared minus 4x minus x squared brackets 2x squared minus 3x plus 1, that's 3. Then 4, negative 5m to the power 3, n to the power 4, the whole thing squared over negative 5, mn squared, the whole thing squared. Then it's 5 9a squared b minus 18ab squared over negative 3ab. So TK, I hope you've ticked. Okay, so hopefully all of us, number one, is not too much of a pain, like very straightforward. I'm sure you guys can see, you know, the typical question we're always asking ourselves for number one is how many terms are in the expression? How many terms are in the expression? We always start there because it's a good place to start. How many terms are in the expression? So yes, there's one. And after asking that question, right, we see that one term we are talking about, what is it made up of? There's a bracket where there's 2 terms in there. Very important. There's another bracket, there's 2 terms in there. Now we take special attention to the actual bracket and the terms inside. Can you see this bracket? Because Bedmer says brackets. So if you look at this bracket, I'm sure you guys can see that this bracket has what in it? This bracket has what in it? 2p minus 4p. What are these? These are what kind of terms? Yes, they are like terms. So if they are like terms, okay, then it means we can add or subtract those terms. Thank you, Zed. Thank you, Zed. Really appreciate the rose. Thank you. So that means if these are like terms, that means we can add or subtract them. So let's do that. 2p minus 4p, because Bedmer says brackets. Let's take care of the brackets. 2p minus 4p gives you negative 2p. Now we have a monomial by a binomial. We've just created a situation now where we have a monomial by a binomial. So that means we can go ahead and distribute. We can use the distributive law using SNL. So let's distribute this term with that one by multiplication. Negative times a net positive gives you negative. 2 times 2, you guys are 100%, which is 4. P times p squared, we keep the base, we add the exponent, that's 3. Term number 1 done. We distribute negative 2p with negative 1. Very important. Negative times a negative is positive. 2 times 1 is 2, and then the p next door. Very good, Abu Zaid. Okay, Bridget. All these people that basically got the answer right. Okay, very, very good. So our final answer is negative 4p cubed plus 2p. All right, there's no like terms, so there's no problem there. Okay, yeah. So I mean, the reason, see, remember that this negative 2p is still having what? It's still attached to the bracket. So the relationship between the negative 2p and the bracket is one of multiplication. Okay, so I mean, it doesn't matter whether you keep the bracket or you don't. All right, remember, even if the bracket is not there, for the negative 2p, the relationship it has with this particular bracket is one of multiplication. All right, okay, so it's fine, we can keep the bracket, okay, for the purpose of you wanting to see the bracket. But whether the bracket is there or not, it's a monomial, it's a single term, so therefore it's fine whether you put the bracket or you don't. It doesn't really matter, as long as you know that the relationship between negative 2p and the 2p squared minus 1 is one of multiplication. So it means distributive law using SNL. Number 2, question, how many terms are in this expression? how many terms are in this expression? But I like CR for life, the idea that you emphasize there of putting the brackets. That's a good one, okay? Because that helps, obviously. This one, how many terms, guys, in this expression? Okay. The untrained eye will say the wrong thing. The trained eye will say the right thing. Okay. Maref, I don't understand what you're saying there. The original is not negative. I don't understand that. What are you talking about? Maref says the original is not negative. What do you mean by that? 2p minus 4p inside this bracket gives you negative 2p. The negative 2p distributed to the two terms inside the bracket gives you a negative 4p cubed. And then the negative times the negative 1 gives you a positive 2p. So I don't understand what you mean by the original is not negative. Maybe you can explain there in the comment section what you mean by that. Yeah, because it has everything to do with the work that we do from the original. So the answer may not necessarily go in line with what you see originally. The work that we do will dictate what the outcome will be of our answer. So 2p minus 4p, guys, there are two terms here. Please, one term minus sign, two terms. Okay, if you say one term, people, come on, we have been here now. Okay, we said a minus sign separates terms. This bracket combines these two terms, and furthermore this bracket has a relationship of multiply with 4p. So that is why we regard this as one term. Then this minus sign separates this from this term, so it's two terms. Please, guys, you see, now if we are still having problems with identifying the number of terms, then it means we're not really serious. Okay, yeah, and again, that thing is going to affect us unnecessarily, and it's going to really be a pain for other problems. Okay, so let's make sure that we do the right things. It's two terms, ne? Yeah. Then this 2p, guys, this 2p, all right, you need to be very careful, is separate from this, but this 4p has a relationship with the binomial. So we know that BEDMAS is what informs what we do. So we look at the bracket, and the bracket has two terms inside, whereas outside there's a monomial. So the first thing we need to do is distribute this negative 4p into the bracket. We can't say 2p minus 4p because this negative 4p is committed. It's combined. It's like a marriage. You can't say, no, we are like terms. No. This negative 4p is not a like term with 2p because this negative 4p is multiplied, because the bracket means multiply with the 4p. Okay? So that's why the 2p stays like that. It waits. Then the negative 4p has fun. Okay, so negative 4p times our 2p, we distribute using SNL, distributive law. Negative times a positive, negative. 4 times 2, 8. P times p squared, p to the power 3. Then again, negative 4p times negative 1. Negative times a negative, positive. 4 times 1, 4. And then p next door. Now we check, are there any like terms? And I'm sure you can see that they are like terms. There's the 2p plus the 4p. Those are like terms. So we can write our answer as negative 8p to the power 3 plus 6p, because you can bring this 2p and this plus 4p together so that they take care of each other as like terms. There's 3 terms now in the expression, so we can add those like terms and we get positive 6 p, because this 2p is positive, this 4p is also positive, and their variables are the same. So we keep the variables, we add the coefficients, we get an answer of positive 6p for the like terms. That negative 8p to the power 3 is basically there as well. Okay, right, that was not too shabby. Now A9, so please BEDMAS, and then distributive law. We can't treat these as like terms because they are not. This 2p is alone. This 4p, which is negative, is not alone. It has this bracket, so it's committed. It has to take care of its commitment, and then later on we can see if there's anything that can be dealt with. Uh-uh, 12. No. 12, we don't do that. I told you, please listen to my explanation. You guys are, this is very painful for me. You guys are not listening to me. You see, there's this question I keep on asking, where I am saying to you, how many terms are in the expression? I don't know if you guys are really grasping the depth of why I asked that question. The reason why I ask you that question, how many terms are in this expression, is because I want you to see the terms that are there and see the relationship that exists between those terms. So if you look at 2p, it is separate from 4p and this bracket. So there are how many terms? There's 1, there is 2, but this negative 4p is multiplied to 2p squared minus 1. Guys, you can't say 2p minus 4p. You can't do that because BODMAS says no. BEDMAS says no. BEDMAS says no. You can't subtract 2p and minus 4p because this negative 4p is multiplied to this binomial. You guys are saying, why not? Okay, and guys, I'm telling you now, it's the why not. I'm explaining the why not. You cannot, because the negative 4p has a relationship with this bracket, which is priority according to BEDMAS. According to BEDMAS, that relationship is priority. It's priority. Subtraction comes later. Now you can't say 2p minus 4p because this negative 4p is having a priority relationship because there's a bracket. And what do these brackets mean? They mean multiply. And even multiply comes before subtraction. So 2p is a term, it's on its own. Negative 4p is multiplied to 2p squared minus 1. So according to BEDMAS, this is the rule that is governing the life that we live. This rule is governing what we do in expressions. This BEDMAS is governing what we do when we have multiple operations in an expression. We don't just do what we want. We do things according to BEDMAS. And unfortunately, those people that don't do things according to BEDMAS, they are the ones that basically find themselves in a situation where the maths is not mathsing, and then they say maths is difficult. Why? Because they're not doing things according to BEDMAS. The E stands for brackets, guys. I mean for exponents, the E. Okay. So brackets first, exponents. D, division. M, multiplication. A, addition. S, subtraction. Subtraction is at the bottom of the ring. All right. As far as priority. Okay. So I don't know if this makes sense, because if you guys are insisting that you want to subtract 2p minus 4p, then it means you have no regard for the law. You have no regard for the rules. You have no regard for the mathematical rules that are in place that govern what we do mathematically. So if we have regard for the rules, that's why this TikTok page is saying maths is a game. You must learn the rules. Learn the rules, guys. Play the game frequently. Then you pass with distinction. You see, you must first learn the rules. When you know the rules, then you will consistently do what's right when you are doing problems. And then when you do the problems, you will get the reward and the satisfaction of getting the problems right. And when you get them right, that further makes your confidence high. Yeah. So that is the law. Brackets, bad maths is the law. It's the rule. It's brackets first. Okay. So for instance, like I said, how many terms? You said 2. Which 2? 2p is one term. What separates 2p from this term? It's this minus. Okay, because plus and minus separate terms. Then you have 4p, but this 4p is combined with this binomial. Why? Because of the bracket. There are brackets there which combine 4p and this together. Okay, so hopefully you understand now. So therefore, okay, the answer must not 6p plus negative 8p cubed. Okay, I mean, that could also be fine, but then still the sign in between, if you write this here as 6p plus negative 8p to the power 3, that's fine. But at the end of the day, this positive and this negative, you need to write finally. Okay, the 8 has a negative sign and the 6 is positive. The 8 has a negative sign. As long, I mean, at the end of the day, it's fine. As long as, you know, it's just that we always like writing our answer having the leading exponent, the highest exponent being the leading exponent, the leading term. All right, so that's just a convention. But even if you said 6p minus 8p to the power 3, that would be fine. That's still true. It still is the answer. Okay, but it's this bad math idea, guys. This bad math idea, it's very important. If you look at the previous problem, you had brackets around the 2p minus 4p. So according to bad math, we start with the brackets. There's brackets here, there's brackets here. We can now look into the bracket, you see? And then check what's happening inside the bracket. There are like terms inside the bracket. So what's 2p minus 4p? It's negative 2p in the bracket. Then we can apply the distributive law because it's a monomial by a binomial. This question here is different from this one. When I asked you how many terms there are here, what did you say? You said there is one term. But when I asked you how many terms there are here, you said there are 2 terms. Okay, so it's very important, that thing. At 9, Swaro, I'll do it at 9, the live for grade 11s, 9 p.m. So in the next 20 minutes, I'll be with you. Okay, let's look at this, number 3 now. I feel like we overstayed and overspent our time there with that problem. Negative 3x into x cubed minus 2x squared minus 4x. That's a bracket. Minus x squared into that bracket. So if I ask you how many terms are in this expression, what will you say? How many terms are in this expression? The number of terms in this particular expression, you would say there are. Very good, Zoe. Thank you so much. No username, you're 100% correct. Yes, guys, there are 2 terms in the expression. Okay, very true. So this here is our first term. This whole entire portion is our first term. This minus sign is what separates it from this whole entire second term. So you guys are spot on. But what do you see about your first term? There's a monomial and there's a trinomial inside the bracket. So that means we are going to do the distributive law. We're going to be distributing this monomial to all 3 terms using what? SNL. So let's apply it. What would be our first term's answer when we multiply negative 3x with x to the power 3? Sign, number, letter. Negative times a positive gives us a negative. The 3 times the 1 gives us a 3. Yes, no username, very good. The x times the x to the power 3, 1 plus 3 gives you x to the power 4. Do the same thing with the second term. Negative times the negative is positive. 3 times 2 is 6. X times x to the power 2 gives us x to the power, there's an exponent 1 plus 2 gives you 3. Negative times a negative is positive. 3 times 4 is 12. X times x is x to the power 2. First 3 terms done. And I mean, who wouldn't want to give you those marks for those terms? I would. Let's go on. Now, there's a negative x squared. We need to distribute that to the last 3 terms inside this bracket. And remember, the sign we also distribute. This sign must be distributed. So a negative times a positive will give us a negative. A 1 times a 2, the invisible one that we don't see, is 2. X squared times x squared gives you x to the power. We keep the base, we add the exponent, we get x to the power 4. Negative times a negative is positive. 1 times 3 is 3. X to the power exponent, we keep the base, we add the exponent, there's an invisible 1 there, x to the power 3. 2 plus 1 is 3. And then lastly, negative times a positive is negative. 1 times 1 is 1, and then x squared is just written as our last term. Tick, tick, tick. Sign, my number, my letter, everything is so sweet and so good. Now the last thing I'm going to do is I'm going to collect my beautiful like terms. Negative 3x to the power 4, bring it close to negative 2x to the power 4. I know username. I think I'll see you grade 10s tomorrow, hey? Tomorrow. I think I'll attend to you the first thing tomorrow morning. And I'm hoping my network will be on point, because at 9 o'clock I'm actually going to have the grade grade 11s. So let's just that, like the grade 9s, there's just certain things I felt I need to stay for where they're concerned so that we can iron them out. Okay, so let's definitely collect all the like terms. Plus 6x to the power 3 plus 3x to the power 3 plus 12x squared minus x squared. So finally we can then add the like terms, the variable and its exponent. What's negative 3 minus 2? It's negative 5. Okay, negative 5x to the power 4 minus 3 minus 2. Then x to the power 3, I'm going to put down. Then 6 plus 3 is plus 9. And then last but not least, x squared, I'm going to put down, because 12 minus 1, that's plus 11. Here is my answer. It is negative 5x to the power 4 plus 9x to the power 3 plus 11x squared. Okay, right. Okay, I think that was quite a longer one, but at the end of the day, you know, it's the whole distributive law using SNL, and then collecting like terms, grouping them together, and then writing our final answer and leaving our answer if there are no like terms. Here at this stage, there's no like terms, so we end right there. Okay, now I want to do number 4 and 5 so that I can leave you with 1 to 5 with the roots and the square roots, and then we can pick that up the rest later on another time tomorrow, maybe minus 5. Look at this problem. We are now dealing with division. But look at the numerator, brackets, exponents, BEDMAS. We must deal with the numerator alone. Look at the denominator, -5 outside the bracket, there's exponents. We must deal with the denominator. So BEDMAS must be applied at the top and BEDMAS must be applied at the bottom. Then those two will be simplified sufficiently so that we can then do what? Then we can then divide the two together. Yes. So we take care of the numerator family alone using BEDMAS. There's a bracket, there's the exponent, it's an even exponent. We apply the even exponent to the sign, the number, the letter, the exponent to the sign, the number, the letters. Okay, so the even exponent to the negative sign leaves us with a positive answer. Then we have 5 squared. We have m to the power 3 times 2, which is 6. N to the power 4 times 2, which is 8. Over. Yes, this is grade 9, Jerry. -5. Once again, even exponent for the bracket inside. All right, the 8, sorry, over -5m squared n to the power 4. The negative can now be multiplied with this one term, which simply gives me -5m squared n to the power 4. Because remember, this -5 gets multiplied with the coefficient that is there, which is the invisible 1. So -5 times 1 gives me -5m squared n to the power 4. When I get to this stage, I'm sure you guys can see what can then happen. After having applied BEDMAS, brackets, exponent using SNL for the exponent for each numerator and denominator, and then multiplying in the denominator to get -5m squared n to the power 4, you can see that there's a monomial at the top divided by a monomial at the bottom. So now I can divide still using SNL. S means sign, N means number, L means letter. Guys, what I'm doing here is that when I apply this exponent for a base where there's just a relationship between the bases of multiply, remember there's this law, ab to the power n. There's this law that you guys learned that this is a to the power n, b to the power m raised to the power p. That's a to the power n times p, b to the power m times p. You multiply this exponent if the relationship between different bases is one of multiply, because a and b have a relationship of multiply. Okay, you can even do that when the relationship between the bases is divide. You say a to the power n times p over b to the power m times p. You multiply the exponent with the exponent of each respective base. Okay, so there's a law of exponents. This is a law you did in term 1. You also did it in grade 8 last year. So this is not a new law. It's not like a law that is foreign. But now some of you are asking about the sign. What happened to the negative sign? This is an even number. So if an exponent is even, how does it affect a negative sign? It changes the negative sign to positive. That's what a even exponent does. But if it was an odd exponent, odd number, you guys know what even numbers are. Even numbers are numbers that are divisible by 2. 0, 2, 4, 6, 8, 10, 12. If it's that kind of exponent, it always changes the negative sign to positive. But if it's an odd exponent, the negative sign would have stayed or remained the same. Okay, so that's a rule you need to write down somewhere so that you don't ever forget it. Okay, I touched on this when I did the basics at the beginning for the grade 8s, the grade 9s here in my previous sessions. So in my YouTube link, the video that I've posted, when you watch that video, you will see that I go through that. Yeah, then this exponent, you apply it for the sign, you apply it for the number, 5 to the power 1. 1 times 2 gives you 5 squared. You apply it to the letter, the variable. 3 times 2 gives you 6. 4 times 2 gives you 8. Same thing in the numerator, in the denominator. You have a -5, but it's outside the bracket, so it's not included for the exponent. But the m and the n, they are affected by the exponent because their relationship is one of multiply. So m to the power, the exponent 2, thank you Mrs. Let, if you apply the exponent 2 to the m, it's m squared. You apply the exponent 2 to this 2, it's 2 times 2, which gives you 4. And then you have that -5 that's waiting very patiently outside. Then you multiply the -5 with the coefficient that is 1, the number 1. -5 times 1 gives you -5. You have the m squared n to the power 4. Okay, so I hope that's clear for those people that were asking, hi, but what happened to the negative side? It's an even exponent. That's what an even exponent does to a negative sign inside the bracket for a single term. All right, and this here, this distributing of the exponent only applies for multiplication of bases and division of bases. It does not apply for addition and subtraction of bases. It only applies for multiplication of bases and division of bases. That's when you can distribute the exponent by multiplication. All right, so yeah, now we are here at this stage. 5 squared is 25, m to the power 6, n to the power 8, -5m squared, n to the power 4. Now we have a monomial divided by a monomial. So what do? We divide using what? SNL. So we go to the sign of 25 and the sign of -5. What's positive divided by negative? It's a negative sign. What's 25 divided by 5? It's a 5. What's m to the power 6 divided by m to the power 2? There's a law of exponents that apply for division of same bases. When bases are the same and we are dividing, what do we do to the exponents? We subtract them. All right, so that's why we say m to the power. What's 6 minus 2? It's 4. N to the power. What's 8 minus 4? It's 4. Final answer. -5 m to the power 4, n to the power 4. Done. Okay. And then I have to love and leave you guys the very last problem. Okay. You guys can screenshot these. This is what I'll start with when we meet each other again. Please screenshot this. I'm just going to give you 10 seconds to screenshot this. This is what you guys can do for if you've done it already, because there was something that I had shared, then great. But if you haven't done it yet, please go ahead and try and attempt and do it. I'll open up with this, and then we'll move on with what we actually have obviously planned for grade 9 officially. But guys, don't take for granted what we've done. What we've done is actually grade 9 officially even. It's the basics. It makes grade 9 very easy when you understand the basics done in grade 8. It makes life easy because you see what you need to do and when to do it. Okay, I think 10 seconds has passed. Now let me just do this last one so that I can prepare to welcome these guys that have been wanting so eagerly to come to the session. My grade 11s, 9a squared b minus 18ab squared over -3ab. What do you see here? At the top, we have a binomial. At the bottom, we have a monomial. we spoke about what happens whenever we have a monomial, a binomial, or when we have a polynomial, many terms in the numerator as opposed to one term in the denominator. We spoke about what we would do as grade 8 learners, okay? Because remember, we have not yet touched factorization, so we are not talking about factorization at all. Rather, we are asking ourselves, what do we do as a grade 8 learner? So when we have many terms in the numerator and specifically one term in the denominator, this is what we do. We split the fraction so that it then has what? The same denominator. Do you see what I did? 9a squared b over negative 3ab, because this is like my lowest common denominator, minus 18ab squared divided by negative 3ab. Then I divide each using SNL. How simple. Split, divide, each using SNL. Okay, this is when you have many over one. Many terms over one term. You always split the fraction and then you divide using SNL. Simple enough? All right. Okay, so see. First fraction, SNL, sign, positive divided by negative, negative. 9 divided by 3 is 3. A squared divided by a to the power 2 minus 1, which is a to the power 1. B divided by b, that's b to the power 0. Negative divided by negative, that's positive. 18 divided by 3, that is 6. A divided by a, keep the base, 1 minus 1, that's 0. And then b squared divided by b, that's b to the power 2 minus 1. You can write b to the power 1. Finally, negative 3a, obviously we know b to the power 0 is 1, plus 6 into 1b. So our final answer is negative 3a plus 6. Okay. Any base raised to the power 0 is 1. Any base raised to the power 0 is 1. So the relationship between 3a and b is multiplied. That's why I put brackets and I put the 1. Negative 3a times 1 gives me negative 3a. And then 6 times 1 times b gives me 6b. That's done. So guys, thank you so much. That was quite a session. Quite a marathon session if you ask me. You guys have been very kind and good. Very generous. Really appreciate the people that came through and were able to answer in the comment section. They brought life. Some of you asked your questions. Some of you were not clear about certain things, but we were able to be clear about those certain things. Okay. Teddy Bear, you've just literally missed that we were doing that kind of session. Solving simple expressions, adding, subtracting, multiplying, dividing. That's basically what we were doing. Yes, indeed. Justice for Kwekwe, indeed. Hashtag all the way. Thank you, guys. Thank you as well. Thank you. Please take to heart many of the things that we've covered here. They will help you a lot. Okay. I am under the idea that people can get level 7 for mathematics. It's not a difficult thing. It's something that is very, very commonplace, but it needs someone who can actually be serious about these rules, and someone who can actually start applying the right approach and not the wrong one consistently. So let's do it one step at a time. Life with Ntabi, no, will not be doing factorization tomorrow. Okay, we still need to iron out, because you see what follows for grade 9 after this grade 8 revision is multiplication of binomials. We're gonna do that, and we're gonna do simple multiplication of binomials. We're going to do complex multiplication of binomials. Okay, so we'll take it one step at a time. Oh my goodness, thank you so much, Mrs. Letts. Sure, how kind. That's very generous. Thank you so much for that hand heart. Okay, I thank you most warmly, very heartily. The very rare things, that's a very rare thing that happens in my life, so thank you so much. You have no idea how much that means. Thank you a lot, really appreciate it. So yeah, like I said, we're gonna do that binomial by binomial. We'll look at simple binomial by binomial. We'll look at more complex problems that have to do with that. So before we can jump into factorization, we're gonna take care of that, the simplistic binomial by binomial, and the more complex ones, a monomial by a binomial, binomial by a binomial, a binomial by another binomial, you know, and all of those things. We're gonna take care of those things. And then after that, after we are sure that all of that simplification and the complex problems that have to do with expanding and simplify have been taken care of, then we will move into factorization. All right, yeah, so one step at a time. We'll eventually get to all these other things that you are mentioning in the comment section. Equations follow after expressions, guys. Okay, so you need to calm down. Some of you need to really calm down. And when I say calm down, you need to calm down in the sense that come down to the basics first and make sure that you are doing the right things with the simplistic, the topics that we've covered so far. Don't be in such a hurry in your head to want to do other topics, but even the ones that you are doing. Remember, maths builds up. You know, if these basics are not fine, you are going to find you're going to have problems in the next topic. So please, guys, the things that I've mentioned here, some of you I could see in the comment section, you are shocked why I'm saying that thing. Because when you've believed a certain thing about how to do certain things, and you are shocked that I'm telling you, no, it's supposed to be done this way. Oh, let us rectify those errors, and let us consistently now apply the right methods and the right concepts. Let's remove the misconceptions. Let us embrace the truth and embrace the true concept, and then start working consistently, applying the right thing throughout, and then we should be fine. I'm gonna end this live, then grade 11s, I'll start with you just now.